Welcome to Get Your FRQ On. This question is from 2019. It's question 6, and it is not calculator active. In the question stem, we are given three functions, f, g, and h, which are all twice differentiable. We are given that g of 2 equals h of 2 equals 4. We are given that the line y equals 4 plus 2/3 of x minus 2 is tangent to the graphs of g and h at x equals 2. In part A, we are asked to find h prime of 2. Fairly straightforward here. Since the line y equals 4 plus 2/3 of x minus 2 is tangent to the graph of h at x equals 2, it must be the case that h prime of 2 is 2/3. That derivative must equal the slope of its tangent line at that point, which is 2/3. In part B, we define a new function a of x to equal 3x cubed h of x, and we are asked to write the derivative of a of x and find the derivative of a at 2. And we must do both parts. We have to find a rule for a prime of x, and then we have to use it to evaluate a prime of 2. Given the definition of a of x equals 3x cubed times h of x, we can find the derivative by using the product rule. A prime of x is 9x squared times h of x plus 3x cubed times h prime of x. All right, so that's the first part. Using that, in order to find a prime of 2, we can just substitute 2 in for all of our x's. So we get 9 times 2 squared h of 2 plus 3 times 2 cubed h prime of 2. Simplifying that, we get 36 h of 2 plus 24 h prime of 2. Now, in order to actually finish this, we have to use the value of h of 2 given to us in the question stem and the value of h prime of 2 that we determined in the previous part of this question, part A. So a prime of 2 is 36 times 4 plus 24 times 2/3. You don't have to simplify this once you have that written, but if you do, you should get 160 as the value of a prime of 2. In question part C, we are given h of x equals x squared minus 4 over 1 minus f of x cubed for all values of x except x equals 2. We are given that the limit as x approaches 2 of h of x can be found using L'Hopital's rule, and then we are asked to find f of 2 and f prime of 2. All right, hold on tight, because this one is a mess. First, we know that h of x is twice differentiable. That was given to us in the question stem, which means that h of x is continuous. Since h of x is continuous, and we know that h of 2 is equal to 4, by the definition of continuity, the limit as x approaches 2 of h of x must be h of 2, which is 4. Now, if the limit as x approaches 2 of x squared minus 4 over 1 minus f of x cubed can be found using L'Hopital's rule, then that limit must be of the form either 0 over 0 or infinity over infinity. Okay. Since the limit as x approaches 2 of x squared minus 4 is equal to 0, we can infer that the limit as x approaches 2 of 1 minus f of x cubed must also be 0, otherwise it wouldn't be an indeterminate form. But if that's the case, then the limit as x approaches 2 of f of x is just 1. All right, since f is twice differentiable, f is also continuous. So, f of 2 has to be the limit of f of x as x approaches 2, which is 1. So f of 2 is equal to 1. Next, if the limit as x approaches 2 of h of x is equal to the limit as x approaches 2 of x squared minus 4 over 1 minus f of x cubed, if we know that that can be found using L'Hopital's rule, then the limit as x approaches 2 of h of x is the limit as x approaches 2 of x squared minus 4 over 1 minus f of x cubed, which is equal to the limit as x approaches 2 of the ratio of their derivatives, which would be 2x over negative 3f of x squared times f prime of x. Okay. But since h of x is continuous, then the limit as x approaches 2 of h of x has to equal 4 because we know h of 2 is equal to 4. Okay. So, the limit as x approaches 2 of 2x over negative 3 f of x squared times f prime of x, if I substitute 2 in for x, I get 4 over negative 3 times 1 squared f prime of 2. But I can simplify the bottom a little. That's going to be the limit as x approaches 2 of 4 over negative 3 times f prime of 2, and we know that has to equal 4. So, simplifying this and solving for f prime of 2, we get f prime of 2 equals negative 1/3. Kind of a mess, kind of a lot going on here. You really have to be familiar with L'Hopital's rule in order to answer these parts. You should probably expect a couple of questions on L'Hopital's rule in the multiple choice section of the exam. You might see it show up in a free response question. You might not. I would probably tell you to expect it every other year, maybe every 3 years. But it is not unheard of, and it is becoming more and more popular in a free response question. In part D of this question, we are given that g of x is always less than or equal to h of x, and another function k of x, which is always greater than or equal to g of x and less than or equal to h of x, on the interval from 1 to 3. And the question is k of x continuous? Well, we're given in the question stem that g of 2 equals h of 2 equals 4. So given the inequalities, it must be the case that k of 2 is also equal to 4. Since g of x and h of x are twice differentiable, g of x and h of x are both continuous. Okay. This means that the limit as x approaches 2 of g of x has to equal 4, and that is also equal to the limit as x approaches 2 of h of x. All right, so this is now an application of the squeeze theorem. Since k of x is bounded between g of x and h of x, and the limit of g of x as x approaches 2 is the same as the limit of h of x as x approaches 2, the limit as x approaches 2 of k of x must be that same number, which turns out to be 4. Okay. Well, now we've established that k of 2 has to equal 4, and the limit as x approaches 2 of k of x has to equal 4, and that is the definition of continuous. The limit is equal to the function value, so we can conclude that k of x is in fact continuous at x equals 2.